what if the I in HCI stands for integration? I'm sure you could come up with other meanings for I, and I'll invite you in a second to do that. But let's get started, and I want to kind of take us a little bit historically through the evolution of computer interfaces, because I feel like we sometimes take this evolution for granted. I certainly do, because I wasn't there for all the steps. Obviously, it all started with really large mainframe computers back 50s, debatable if it's even before, where computers took like up entire rooms, and you could get a little slot to interact with this computer, maybe run programs overnight. You typically interacted through command line interfaces, punch cards, the whole thing. It was very exciting, but only a few selected group of people had access to one of these machines. Obviously, as you all suspect, this evolution keeps enhancing with graphical user interfaces. Computers go to sort of not just a few selected groups of people, like at universities and at industry, but go to everyone's homes and offices. Society flourished, desktop publishing, music production, the whole thing really changes with this idea that graphical user interface is just sitting there in your desk. And of course, mobile computers are probably the one that you all have in your pocket. This supersedes the number of people on the planet, the number of smartphones, which is really impressive. And it's this moment where computers are just with you anytime, anywhere. You can access information very rapidly from pretty much anywhere. And of course, I'm sure like half of you have a smartwatch of some sorts, and this is the moment where the computing devices not are just with you at all times, but are also in physical contact with you and can sense physiological signals, your state, heart rate, etc. No wonder that this is the big market behind these devices. What I want to say is that at every of these jumps, as we move from one interactive paradigm to another, a lot of new benefits are merged. And these are the ones that I think sometimes we take for granted. Because as a new interaction is possible, society actually tends to shift. I want to show you some examples that maybe in hindsight look kind of obvious, but at the time were really provocative. I remember the first time I accessed Google Maps on my parents' basement computer, and I was like, why do I need to watch a map right now? Because I'm not going anywhere. I had to print the map and even walk with the printed map. It was pretty impressive, but it was not the same level of revolution as when we are able to have the maps with us in our pockets. This is, gig share economy, food delivery, local economy, people trading goods, etc. It's possible with the same interface, same metaphor, same interaction, but just because the device substrate changed and became mobile. And of course, the same story is going to happen over and over. Mobile devices already had some preliminary sensors, accelerometers, some of them had heart rate sensors and others simple physiological sensors. And the WIST community, the HCI community, was very pioneering in trying out early health type devices with mobile devices. But it's when the same data was accessible through the on-skin wearables that all of a sudden it's mindfulness applications and fitness applications and tracking your movements and your sleep, etc. All of it could be done with a mobile phone. It just isn't on your skin. It just doesn't make sense. Okay, so idea is every of these interactions is useful. And so behind this talk is the idea that if we could just understand what the next one is, like what happens to these bubbles, essentially, one is getting smaller, one is getting closer. If you could just understand what's happening, and I want us to think all together. I'll show a solution that I think is the one, but I really want us to think all together. Then we can kind of understand what maybe the next generation of these devices is. And through this exercise, if you will, of trying to think about the next generation devices, I would say we might uncover, again, new benefits, new downsides, new challenges, new things to look out for. All right, so let's take a little step and just walk through the factors that are driving this evolution. Obviously, one of the things that jumps out to the eye is that the device itself, physical hardware, is getting much, much, much smaller. If you ever touched a VR headset, you can appreciate how small the hardware that is packed in one of those devices is. It's just like more power than this inside a small device. So the first sort of evolutionary pressure is this notion of miniaturization. You could talk at length about what powers this, but let's just say that, Moore's law, Denner's scaling law, all the fun stuff that you've heard about before. But from a more HCI kind of perspective, there's another really interesting thing happening here, which is the relationship between users and devices, which I'm depicting here as like this distance metric. That's also getting shorter, because if you ever use one of these computers in the 50s, you could spend some hours, but it was in another room, and then time share with someone else. It was physically distanced from you. And this one is in your office, physically distant, not by much, by a few meters, and this is in your pocket, and then the other one is just with you at all times. So there's this shrinking of that distance. And I want us to keep those two kind of evolutionary forces in mind as we kind of think about what is next. And obviously, as you guessed from the title of the talk, what I think is happening is that this bubble, the little device bubble and the user bubble, are sort of getting closer and closer and closer to the point that we sort of have to recognize what would happen if we let them overlap, right? What would happen if we let the device and the user sort of integrate to some extent and kind of imagine a device that is kind of part physical, part of you, and so forth and so forth. I'd argue that, of course, these devices are not going to be that different from all the others. They're sort of, if you notice, every single of these revolutions piggybacks on the benefits of the other. I'm imagining that these new integrated devices would still have tons of computing power, be with you at all times, and be context aware and have sensors. Like, they're not going to change with respect to that, but it'll change with respect to the things that make sense to do with this kind of device. So I want to show you an example. This is the latest thing we've made in the lab. And you see a user here, she's wearing a suit with electrical muscle stimulation, full body, so you can move her arms, you can move her legs. She's also wearing a suit with IMUs for full body tracking, and she's wearing also meta headsets to see what, so the system can see what she sees. She's struggling with getting out of the bike pedal. So she asks for help to get out of this specialized shoe that she's wearing for the first time. System generates instructions taking what it sees from her.
I'm going to move your right foot.
EMS, continue.
And after that, electrically stimulates her leg to twist the heel. This is a little weird motion if you've never done it, and click off the pedal. Now she faces this bike rack,
EMS, help me with this bike rack.
which again, she has never used before, and doesn't know how the mechanism works, doesn't know the physical movements you need to perform this. The system again looks at it, generates.
I'm going to move your right arm and hand.
EMS, continue.
And again, does the muscle stimulation movements required to kind of show her physically the type of embodied knowledge you need to like click that thing. This one's actually click up and then biceps down, and so forth, so forth. All right, so I don't want to say that this is the future by any means. This is a prototype we made a year ago in the lab or so. But I think it's an illustrative example of one of these types of devices. But this talk isn't about muscle types of devices. It's about all kinds of integrations, right? You saw that this device made use of AI glasses, made use of voice control, made use of indeed muscle stimulation. In fact, this existing product, the Tesla suit. But you can start extrapolating, and I think Kai and UIST are always really good pointers to find emergent new ideas to what if people would share their muscle knowledge across individuals. Maybe they're dancers, maybe they're doctors trying to understand how to perform a movement together. This is work by Jun Nishida before he joined my lab, I should say. Or what if you're like a pianist, already a professional, and you want to optimize, learn how to perform better. This beautiful exoskeleton by Furuya at Sony actually helps even professional musicians to think about their craft and play in a different way. You can think of this as exoskeletons for helping people lift or prevent injuries. You can think of this as like this whole new brave world of not just prosthetics, but like real augmentations. For example, this is a third thumb that is controlled with your foot. This is done by Claude and Mackin, and they're really exploring what would it mean if you had more dexterity than physically human possible. It's beautiful work, and you should come to Kai if you want to see this stuff. Of course, literal physical augmentation is also possible. People are implanting, RFID chips in the swords to scan their hands in the subway, enter their cars, and etc. And that's always been happening for maybe 10 to 20 years. But also this sort of real cutting edge of medicine. This is Scott Ingrid. He's a patient at U Chicago, works with my late colleague Stephen Maya and my colleague Charles Greenspan, and he has a medical implant in his brain that is able to make him feel, for example, what a robot arm feels. This isn't just control, this is also he can feel the touch as it stimulates the part of his brain that generates touch. And he's very happy about it. You can see lots of stuff online about Scott talking about his implants. Now what I want to talk about is, again, if every of these steps brings benefits, what could be the benefits? And this is, me speculating, what could be the benefits of all this integration? And the first one I've already alluded to is the miniaturization, but I want to drill down and explain why this stuff gets smaller. So I'm just going to go back to the first slide of the talk. This is a device I made 10 years ago to the state, in fact, that allows you to sort of, with muscle stimulation, change parameters. And in the meantime, the UIST community has been really excited about muscle stimulation. Use some of Jun Rekimoto's pioneer work on this stuff. And you should ask yourself, apparently there's 151 papers. Why are we excited about this stuff? This is really weird, stimulating muscles, people out of control. There's something dystopian about this too. So why all this excitement? And I think it's because it actually allows us to miniaturize devices in a completely new way. If you compare the muscle stimulation with sort of the traditional robotics approach, where you use motors and exoskeletons and large batteries to drive and move the human body, what we find is that it can circumvent those limitations by sort of directly stimulating neurons. You don't need all this external hardware. It's actually removing hardware, which I quite like. It's less hardware than I thought, and results often in very much smaller interfaces. This one can do force feedback, not as precise as an exoskeleton by all means. If you want to talk about this, is one of my favorite topics. But what's really interesting is if you look at the last years of Chi and UIST, you can see a little bit more than just force feedback. You see people miniaturizing temperature. This is work from the former student Jazz Brooks using chemicals. But again, with those implants, like Charles and Sleeman's implants, you could imagine even kind of replicating the glove-like feeling, but just by stimulating your brain rather than actually having to wear the glove. And if you want to go real crazy, Christian Holtz did a beautiful paper more than 10 years ago now, where he just took the whole hardware, almost like a smartphone, and put it inside the body. And I think that's a really interesting idea of it's certainly smaller because it's just not even with you. You should check out that paper. It's not as scary as I'm making it sound, and it's very beautiful. Now, the other thing that I think is quite interesting as a benefit is that it puts a new spin to the word user-centered. I'm using this in a very provocative manner, just to warn you ahead of time. Here's me giving a talk, using a clicker like this one, external device. What we can do now is sort of play this game of what happens if we internalize the device? What happens if my hand becomes the clicker? And so this is a paper I did a while back, 10 years ago, where I'm actually giving a talk. You can see my hair is shorter. That's the only difference. And as the talk is happening, the slides are moving, my hand moves with electrical stimulation upwards. Of course, I'm in control. I can rewind. But it's still my body. I can dismiss this thing at any time. It's just the clicker happens to be my body. So when Alexander here throws a mark at me, the whole interaction stops. I go back to my normal hand self, and everything goes on. And I guess I was already drawing the bubbles there. It's a long time that I've been playing with these little bubbles. Again, I just mean it user-centered in respect that the user is literally at the center of the device. It's literally, you have to design interactions, thinking of the body and anatomical constraints, physiological constraints, the whole thing. What I want to highlight, though, that is kind of interesting is, again, we're taking out pieces of electronics and trying to see what functionality from the user's body already performs that, and we could even perform it in a more sort of harmonious way. Again, you can replace handheld devices. For those of you in the audience who don't know this paper, go check it out. You can literally replace your entire phone with your hand as a proxy. Fantastic work by Sean Gustafson. And really at the super cutting edge, people are actually even trying to replace screens by using brain stimulation. So in this case, magnetic stimulation, PG thesis of Novi from the Media Lab, lots of work in neuroscience like Dubé's work on this. And here, electrical stimulation of the brain, Higuchi's work. What this does is make you see little dots. Okay, there is no screen, you're seeing little dots. And in fact, Higuchi takes us in a really cool direction where you're being guided left and right by seeing these dots flashing left and right. Remember, there is no screen. This is AR screenless. So it is pretty cutting edge. And I like this idea of sort of envisioning how far this can go if we remove the electronics. My favorite part has to be this one, which is, can this new generation of computers allow us for new ways of thinking? And I feel like Takeo was talking about this in the Q&A too. We've been sort of stuck for very good reasons with the symbolic way of interaction. right? Not just Xerox PARC sort of classic stuff, but even more, classic is Douglas Engelbart's invention of everything we needed to create the GUI. And when I was doing this talk last night, I'm still stuck on the GUI. It's beautiful. It works really well for making PowerPoints. I'm not saying we should tear this down. However, my question here is, well, the power of LLMs and AI and et cetera and learning can be very powerful too, but is this the only way that we're going to learn, again, through this sort of idea that we're inputting text through learned text reasoning and then outputting text and sort of this textual kind of spin to it? And we all know that our bodies are much more than just text, right? Like, we have all kinds of senses, we have all kinds of experiences, and some of us can't even do visuals, so that already seems limiting as well. So again, imagine trying to perform the exact same polynomial. By the way, the LLM did a great job at solving the polynomial that I gave it. But trying to do this in a more embodied manner, in a manner that you kind of get an intuitive feel for what the equation means and how the plot is going to look like. This is a paper 10 years ago at UIST. Again, just want to highlight that it uses muscle stimulation. So the person here is writing the polynomial down and then grafting it. So this is still the user, and then the muscle stimulation is going to kick in right now, and it's sort of drawing the plot for you. But remember, it's your hand that is drawing the plot. You're feeling, oh yeah, this is like a quadratic thing, so it has these two poles, and you start kind of getting a feel for what it means to do this. And you continue and you solve it, and I'm sure it takes much more time, so not easy and fast, much more time than ChatGPT does to solve it. But what decades of research in neuroscience and learning sciences keeps finding is that gestures matter. Like even mathematics, I had to plug in Susan and Howard, they're psychologists at Chicago, they do great work. I had to plug one of their papers here because it really shows gestures even help learning mathematics. So you think mathematics is purely textual and totally abstract. Well, we have a body, so it can't be purely textual and abstract, at least with our current body. All right. So that's what I mean with like new modes of thinking of interfaces. And please read the subtitle because there's lots of people doing work here, not just me. But in fact, I want to show not the physical one, but really like maybe other things. So Dunry et al. Had this really cool paper, Augmented Humans, passed last year potentially, showing brain stimulation of the visual cortex, creating a little bit of like heightened sense of spatial awareness. So it's like a sense of spatial reasoning. You can think of Ted Starner's work, which I'm really a big fan of, and Caitlin and others are responsible for this, where they use passive haptics. So you can learn things while you're not even paying attention. And that's a subconscious kind of reasoning. And even more provocative, the work of Adam Horwitz, where he like interfaces with your dreams and incepts things so you can be more creative. It's a kind of unconscious reasoning. And even more, I think, forward-pushing, this is a poster by Mia, I don't know if she's here. It was last year at WIST, and this was my favorite poster from last year's posters. And she created this interface that interfaces with your gut. Measures the gut, vibrates your gut, kind of gives gut feelings, creating sort of interoceptive mode of reasoning. This has nothing to do with what the devices do today, right? Your phone doesn't care about your gut feelings. All right, and then last on this trajectory of possible benefits is pushing the boundaries beyond what's humanly possible. So now I'm talking about abilities that you physically cannot perform with your current body. One sort of simple one that we've been doing a lot in the lab, and Yuda is showing this tomorrow, is faster reaction time. Here he's using brain stimulation. We've done this also with muscle stimulation. You can see a person here having like a superhuman speed reaction time. In fact, if you buy the Guinness Book of World Records, that isn't there. It's kind of fun, but it says fastest artificially assisted. So it's like, it's fake, and they came to the lab and they did measurements, and they were like, great, 15 milliseconds. But you can keep pushing this so much further than the naive stuff we've been doing. Again, Sleeman and Charles Greenspann's implants allowing Scott to feel remote touch. Nobody can feel remote touch. This is absolutely a superhuman sort of ability. People at HCI have been exploring with magnet implants to feel electromagnetic waves. Really love this paper using muscle stimulation to feel the Wi-Fi quality. Imagine entering the room at WIST and you're like, oh, the Wi-Fi is kind of crappy. This Wi-Fi is great, I hope. And my former student Jazz did some things about smelling and stereo, and people can locate gas sources and really, really at the cutting edge. I don't know if you saw this paper at Cell early this year. this is a type of lens that allows you to see, or will maybe allow people to see in near infrared light. So really, really crazy, obviously, wavelengths that you as a human do not biologically have access to. All right, I want to give a little bit of reflection and give you guys homework, which is I'm feeding this to you as like, aha, it goes there, integration and Pedro's work, it's perfect, please cite me. But it's not true, that's not my intention with this talk. My intention is actually to ask you what you think are the possible next steps. So take out your phones and go to this website if it doesn't crash and if the web Wi-Fi is good. I have no idea if this is going to work. And you can also just type vision.plopes, which is with an S, not with a Z, .org, and then you can draw what you think happens to these two bubbles, like seen on the video there. Now draw one bubble, draw another bubble, and then go to the bottom and say, send to Pedro. Okay, and then I'll get it there if the Wi-Fi works, and then in a few minutes, we can see what you guys thought that is the next feature of these bubbles. And you can draw whatever you want. It's completely anonymous. It's randomizing. They don't even have your IP address. All right, cool. I'll leave the QR code there if people want to still play with that while we're talking. And while that is happening, we're going to challenge the elephant in the room, which is artificial intelligence. Now, I don't have to do much here because June, Ivan, Arvind, and Wendy did great jobs at covering all possible visions and futures. This is the visions track here, which you should go and watch these. And these are all clickable, so you can just start watching. But I want to pick on something they didn't talk about so much. And again, it makes sense because I'm the one pushing here, so I should be talking about this. If this happens, if interfaces integrate with our body and allow us to do physical things, then this new generation of AI that is very, very, very infused with robotics sort of seeks out to automate everything, right? And great work here, Google DeepMind, Gemini Robotics, doing things that this is, learned on the spot. So this is sort of inferred on the spot. Really amazing work right there, and their video has more than that. And maybe to some extent, people will start doing that with integrated devices. And maybe something already happened. Max Pfeiffer's super pioneer work 10 years ago, by now, sort of using muscle stimulation, you can see an electrode there, to steer someone so they don't hit that lamppost, okay? Automation of the body, very interesting. My student Romain did something along these lines. This person here automates a repetitive task that she doesn't want to do so she can focus her cognitive load on writing an essay. And by the way, they ate the caramel and it tasted great. And, that sounds great for these tasks, safety tasks, boring things. But what about things at the core of being human? Like, are we going to automate, self-expression and art, meaning-making through discovery and through science? And that seems really difficult. Here's an example. Like, I don't think we should automate either with robots. I don't want to go to jazz club and a robot is playing. I also don't want to go to jazz club and the person is playing through muscle stimulation. That just doesn't seem interesting, right? So is there still a role that this AI revolution inspired robotics can play in future interfaces? I think there is, but it's sort of as a learning tool, as a tool for exploration that lets you then take out the tool. In this case, I'm just explaining that through the work of my student Yoon, taking out the electrodes and showing that people were able to learn the melody through the muscle stimulation. In fact, they learned it really well through the muscle stimulation. I'm sure you could do the same with a robotic. You're watching a robot, you're maybe experiencing some of the movements of the robot, and you learn and then play it without the device. Kind of key element right there. And actually, they did that a few hours after. So now, like to the point that Takeo was making about new media, new forms of expression, that might also be a possibility. I don't know. This is where the thing starts to be quadratic, speculative, but maybe body automation can also arise for new forms of art. Again, work from our lab. Here's Aki. He's actually playing with the muscle stimulation. He can record and loop parts of his body. He can even send the loops to different limbs. So he's going to record this one and then send it to another limb as he presses a pedal. It automates that, and now he can play the drums in a new and creative way, paying different kind of attention and intentionality to the way he's drumming. All right. Now, I promised we were going to look at that, and I don't know if has it crashed?
Not yet.
Nice. This was done overnight, the code, so you know. Whoa, okay. Oh, you guys don't see what I see. Whoa, that's way more than I thought, and it didn't crash. That is very cute. I don't know any of that. But some of these things we see a lot, which is sort of like, sure, the integration, sort of sometimes we see there we go, the perfect, I knew this one was going to show up. Perfect integration, I don't know what this explosion looks like. We see a lot of this one, which is sort of like a IoT kind of style, many devices around you. It seems really simple, these bubbles, but boy, you can do a lot of thinking just through these sketches. So, kudos to Takeo for bringing the value of sketches as well. All right, I'm going to start concluding and just give you a few challenges. The first is that I, pushed my vision onto you, which I shouldn't, and I said, integration has to be the muscle integrated or bodily integrated devices. It doesn't really have to. I also want to say that some of my students don't work on this stuff. What they do, though, is that they use this question, what if the I stands for integration, as a metaphor for problem solving? And they go to other things that have nothing to do with, nothing here has to do with muscle stimulation. And they, integrating organisms, okay, what if this happens? Oh, integrating distractions, what if this happens? And so forth, so forth. So maybe it's a helpful tool or a strategy to pay attention to different facets of HCI that we don't always pay attention. Self-expression, I/O bandwidth, relationship with devices, sense of agency, and so forth. The other challenge that I want to highlight, and maybe this is a more philosophical tone to end the talk, is what if this goes bad? What if we lose ourselves in this integration and we're no longer humans? And this is where I think there's kind of a threefold strategy to tackle this. The first is, of course, we got to decide ethically, what do we think these devices are for? What do we think these devices are not for? And we probably actually should collaborate outside of this room to do this. And many fields that have been pushing very provocative devices like brain stimulation and neuroscience, they've been doing the ethics run for much longer than we did, like with muscle stimulation or whatever it is. And so you could probably collaborate with them to sort of understand what are the scopes and limits of this. And it's beautiful that the AI folks are actually taking this pretty seriously too. The other one that I'm super excited about is that all of a sudden in HCI, like sense of agency is a really key factor. And it was always a key factor, it's just we didn't have like 10 papers a year or a conference on this. And these are just a small selection. So go read these because people are theorizing what happens to our sense of agency with these integrated devices. It's easy to sense of agency, maybe like if I press a button and nothing else is happening, okay, sort of the dichotomy there, me and the computer. But if we start to talk about the green part here, who has the agency is kind of blurred in those lines. And so these papers are really doing a great job at theorizing that. I think we should also do experiments on this. So my lab has been doing some experiments about the trade-offs. If you speed you up by 10 milliseconds, does that feel weird? Oh, 100 milliseconds feels weird. Okay, interesting. Where does that come from? And we try to examine the brain in action to understand what are the neural correlates of what gives rise to this sense of agency. Can we optimize so the devices feel really right to you? And last, coming back to an earlier point, I think the final piece is, can we create devices that we're not feeling dependent from? And this is really challenging. The stuff that I create is often feels kind of dependent to me too. But can we aim for devices that learn and rather than replace? So in almost all the last papers we published in the lab, we're sort of slowly trying, and it's painful and it's not fun sometimes, to examine not the device at work, but what happens to people after. So we ask participants to remove your guys' device, and then, okay, nothing happened. Okay, well, people are dependent. Or, now it happened. They became better in some aspect. They're not dependent on this device. This device is actually, augmenting you in the same way that maps augment you. Even if the map is not there, you remember the Cartesian coordinates. All right, I didn't do actually this work, so this should come as no surprise to you. These are the people that I should really be thanking. My lab, Human Computer Integration Lab in Chicago, did all this work, and also thanks our sponsors. And I'm happy to take any questions that you have.
Thank you, Pedro, for the engaging and thought-provoking talk. I see a few hands. So while the speakers are handing out the microphone, maybe we can start with a short question on Discord. The question is about how do we deal with human body autonomy? I think part of it has to do with sort of personal acceptance of these integrations.
That's a really great question. I needed Yoon here. She knows the name of that paper by heart. There's a really interesting paper. I'm going to say it's 22 MUM, the Multimedia Conference, about sort of the acceptance of some of these augmented interfaces, some of these muscle stimulation interfaces. And you can definitely see that there's a spectrum. There might even be cultural shifts as well, where some people might be really excited to try this out. People are tech savvy, people who come from a culture where cyborgism and all these ideas aren't like so new and been really baked into society. So I think there's a really big disparity there, and I should emphasize all of this is still very much in the research, in the arts. There's a lot of arts using these kind of integrated devices. But as it breaks away from that, I think that question becomes ever more important. And I think maybe it gets to a point where we sort of have to eat up the disadvantage. The main disadvantage here with integrated devices is that it's you. So it has to be like, you have to like it. You have to accept it. It's not like, oh, my iPhone, I don't like it. I'll buy another one. No, this is your hand clicker. It has to feel like your muscles. It has to feel like your movements. So for the designers, this is going to be a cool challenge, not to say nightmare, but of customization and really like users must be in control of how they want this thing to feel like at the end of the day.
Great, we see many hands. Who has microphone? Oh, okay, yeah.
Oh, this person.
Right, Lopan from National Taiwan University. Yeah, it's really great to see the good old days in HCI. Yeah, and really, this is a really interesting talk, and I just want to point out there's an interesting coincidence and reflect back a little bit toward to the Takeo's talk, because Takeo just talked about the shoe hot lay, right? The obey, break, and the lead. And I found it really interesting because the vision on the abstract level is actually completely inverted from yours, right? So because you are talking about actually bring these devices, external devices, into like more integrated form. So I'm just wondering, maybe this kind of like a very difficult question to you. I hope you might have some thoughts about the implication behind this. Yeah, there could be some connection behind this, or maybe this is gonna be a great debate, right? Who's actually going to be the research approach, for example?
Yeah, I really like that, and just to make sure people understood, Takeo had the bubbles separating, and all of a sudden my bubbles are coming together, so what's going on? So Lopan asks what's going on. I think this is sort of what, in philosophy would be kind of like a categorical distinction, or categorical mistake, sometimes they call it, where I think the reason why the bubbles are separating in Takeo's case is so that you now have this sort of power to break away from the only skill that you'll learn and start to uniquely express yourself. And I think in my case, it's more of a lower level type of integration where it's just like the device was very distant, and so in fact it was going to be very hard to learn from a device that is so distant from you, doesn't speak body language, doesn't speak all that. So it integrates at that sort of very low level boring stuff. But maybe on top of that, you can definitely imagine what Takeo was talking about. You would learn a skill, rip off the device, and then you got the middle point breakaway, and then the device has no power, you trash it. You can still play piano, now you're like in the leave final part. So maybe they can coexist at the same time. I just think they're belonging to different categories. That's a great question.
Over here, and then.
I'm Dieter from UBC. I'm curious if you have insights on, especially with accessibility devices that people may become reliant on for everyday functioning, how can we as designers protect people from when these devices become obsolete or when they're no longer maintained?
I'm going to be somewhat limited in my answer there because I don't do that much work in accessibility, and I dabble badly in that space. Because I think the folks who know that, the folks who design those devices, and especially people who are like co-designing those devices, know much better what it means to them to draw the line of dependency and whatnot. We did a paper last Kai where we created a device that allows blind people to see with tactile patterns on the back of their hand, and it was designed by Jin Kim, who was blind and was working with us at the time. And the users testing it were also blind or low vision to some degree, and all of them, had critiques of their device, and all of them said, what I like about this device is that it doesn't encumber my hand, because no way in hell I would not use my cane ever and just use your device and no cane. So I think there's that level of importance to understand that codependency. And again, I'm not in a position to speak for accessibility because I don't do that kind of work. I think it's really important to set those boundaries. But I think that dependency piece plays in an even more complex way when now the device is meant to assist you in that capacity. And you can see that in the way that people, for example, really value in the skill of using the cane. And still today, where there's other alternatives, will drill down that exercise because that's a beautiful device too.
You have a question over there?
Hello, Jack Corbin from.
Where are you, Jack? There. This is a big room.
Yeah. Congrats. Wonderful talk. You've convinced me of this idea that the I should be integration. What I am now questioning though is the H as human, which is that looking across all of your wonderful work, it's really focused on the human body and specifically the singular human body. And this notion of like computing going from desktop to mainframe to wearable is one way that computing has integrated itself within our society. Like if we look at the ceiling here, computing has also integrated itself within its environment.
Absolutely.
And so I almost wonder, like, what if the H shouldn't stand for human, but should stand for harmonious computing integration? Do you think that computing will still have this dual track of environment and body? Or do you think that one will burst? Or if they do come together, how do you think that your work would explore and negotiate with that boundary?
Two things immediately come to mind. The first is you already have the title for your vision talk, so just go do it. It's amazing. I love the harmonious computer integration. The second one, and I think you're absolutely right, and that's why I wasn't surprised to see the diagram with the many nodes, because I don't think we're going to break away from that. There's technical substrate reasons why we're not going to break away from that, and the other reason is if we break away from anything, even mainframes are still around. They serve a very different purpose. They're sort of supercomputing-like things, but we didn't break away from any single of these tools. We just gain another one, the repertoire sort of increases. And so I think to some degree that will happen. Now, some tools become sort of more trendy or popular or sort of push the mainstream way more than others. I think that's what happened with graphical user interface pushing so much the symbolic type of thinking, which makes perfect sense. We're highly symbolic animals. But I think that balance I can't predict. I'm not very good at doing predictions. It could shift a little bit. I think we're seeing wearables. I think we're seeing a lot of like haptic things almost breaking into the more mainstream-like style. So maybe the balance can shift a little bit. But I don't think we sort of just, it's now only integrated and single individual. No, I think we'll keep networking. There'll be continuously this sort of like types of interactions around us, types of devices around us, and I think your comment is very well taken. This is more of adding one than replacing one.
We'll get a question from here, and then we're there. And a question over what?
Thank you for your talk. So you were talking about ethics and going on disability, and then also on Jack's question is, what's the boundary that we should step as a community in how far do we want to do this integration with the human body, and also because as we've seen with our technology, it has been used to change in a bad way the social aspect of how we interact with our culture.
Yeah, I think the example that you give is perfect, right? Like the internet and all these things were there, and there was a lot of early sort of prescriptive approaches to try to regulate, and this is how the ethics should look like, and etc. It is very difficult to, in the ground, sort of prescriptively put regulations and put down milestones and markers, because society is this amorphous, sort of ever-changing phenomena that we all share. So you're all shaping the future of all these things at all times. That being said, that does not replace at all the fact that we should engage, with bioethicists and neuroethicists. In the neuroscience, they've been doing so much more discussion on what it means to have implants, what it means, including even stuff that for us is like, oh, it's a really boring little simple device, but they're looking very carefully at what it means to have that kind of augmentation, a little sound augmentation that beeps when you hear a particular sound or when you see a particular person, etc. So I think we should have that discussion very openly at our conferences. We should have papers around that topic, should have convenings. And the folks who can start to sort of influence legislation, influence, etc. But just want to point out that the prescriptive way is difficult here. This is made by society, like all what we call the morals and the ethics aren't something that, somebody puts down one day, it's something that sort of evolves. The uses of computers today already surprised me. Like when I was a kid, I never imagined that some of the things we do with computers today would ever be acceptable. And here we are sort of struggling with that and thinking about stealing content from artists and etc. and struggling with that. And I'm sure by having these discussions, not by hiding it, we will sort of make significant progress in that direction. And this is a little further down the line, but I think here discussion is very much needed as well. And I'm happy, like a lot of the papers that get cited on this sort of more integrated interfaces type have like a robust ethics discussion. Either maybe sometimes at the end is an afterthought, and I'm guilty of doing that, but some of them like up ahead, forefront, and that's really, really cool, especially Cotton and WIST. So yeah, it's not an answer, but more like I agree with you and we should do that.
Okay, we'll take one last question from.
Okay. Hello, my name is Sophia and I'm from Samsung. It was a great talk to listen to. My question is more about what happens to the humanity in this HCI or IS integration. The reason I'm asking for this is because, well, computers are great tools for humans, but at the same time, they're driven by humans. And as young people say, I feel like the driving happens when we go and touch grass and stay away from the computers, right? So when the integration happens and computers become part of us, what happens to us as humans, right? So what do you think about that?
Yeah, that's a beautiful and kind of like super complicated question, because there's like parts where this just makes it worse, and there's parts where I actually think this makes it better or more interesting or different. In a lot of the computers that I was highlighting here, and again, not just my work, like little implants here, little device with a magnetic thing that allows you to feel EM fields, they actually allow you to attune your senses to a particular thing in the environment without, pulling out your smartphone and looking at tons of other stuff in your feed, getting distracted. So in a way, and I'm going to use this wrong because I don't know the lingo well, it's kind of like touch grass but digitally, and like feeling that particular, honing in on a particular sense. I started using a device made by UIST that I'm wearing right now that times when I'm giving talks. This just gives me little impulses when I'm giving a talk. And I don't have to look at my phone anymore during talks. I don't have to go there and look. I just kind of know if I'm behind or ahead of schedule while doing the talk, because it gives me little impulses. And to me, that's kind of a way to not be distracted. If I could pull my phone, which looks really ugly, because it's connected to this whole thing that UIST made, so it looks ugly, but imagine it didn't look like a normal phone. Then I would look at it and get distracted, and okay, 75 minutes, and then it would be a completely different kind of interaction. Again, I'm not saying all of this makes it better, but I think what you're hinting on is a really interesting challenge for the WIST community, for the HCI community. Can we design like super specialized interfaces that only do this one? It's like tools, and Michelle had a beautiful talk and visions about tools and interfaces and screenless and appless. Do this one thing very specifically beautiful, talking to one sense, and then you feel kind of like not immersed with this distraction world, but more in tune with your body and what you actually want to pay attention to. I think that's possible. I'm sure this can be misused to do the opposite of what I just said.
Okay, with that, let's thank our speaker.
Thank you.